Hey Chemistry, Mrs. KJ here, and I'm doing the Unit 3 test review via YouTube for two reasons. First of all, just had too many text problems with Blackboard Connect today, and so I figured I would do it later tonight. And the other reason I did a YouTube video is because I really want you to be using this as an interactive tool, meaning I know you can't respond to me live, but you can hit the pause button whenever I ask a question to make sure you know the answer to it. If you need to watch it once and then watch it again and hit the pause button the second time, then do that. So I'm trying it a different way to see if this is more helpful. So if you found it more helpful or less helpful, let me know. I'm very open to ideas and suggestions. Alright, so if we look here, we have vocabulary words: homogeneous mixture or solution, solvent, solubility, saturated, supersaturated. The biggest test help I can give you when you have matching, no matter what test it is, start on this side, because you have to read this whole big long thing and then just find the one answer that matches it. If I start with homogeneous mixture, now I'm reading all these big long paragraphs over and over. So pressure is used to force more solute to dissolve than normally can at a set pressure and temperature. So go ahead, hit pause, get your answer for that one. The next one, what gets dissolved? The next one, what is doing the actual dissolving? This can be any phase of matter, but usually it is the liquid such as water. Our next one, if only 10 grams of sugar can dissolve in 1 liter of water at 5 degrees Celsius. And my last one, a mixture of 2 or more substances that is the same throughout, even at the molecular level. Alright, so hit pause if there's any that you didn't get, and here's our answers. So the solvent is usually our water, it's what's doing the dissolving. Homogeneous mixture or solution, a mixture of 2 or more substances that is the same throughout, even at the molecular level. Saturated, it's how much can dissolve in a certain amount of the solvent at a certain temperature and pressure. Supersaturated means super meaning more. So you forced it. Pressure is used to force more solute to dissolve than normally can at a set pressure and temperature. So first you have to get something saturated, and then you can use pressure, for example, to supersaturate it. What would lemonade taste like if it was too concentrated? So hit pause, get your answer. Well, it would be very sweet, or if you used a lot of lemons instead of a lot of sugar, it would be very sour. Either way, it would have a very strong taste, very concentrated. What would it taste like if you made a dilute solution of lemonade? And how do you make a dilute solution? So again, every time I ask a question, hit that pause button, answer the question, and then hit play again. So it would taste watered down, and to have a solution become more dilute, you simply add more of the solvent, which usually the solvent is your water. If I have 45 milliliters of water and 55 milliliters of pineapple juice to make 100 milliliters of solution, what would the percent composition be? Percent is a part out of the whole, or in other words, the part you want divided by the total. So what part do we want? What is our total? We want 55 milliliters. Specifically, we want to know about the pineapple juice. And our total is 100 milliliters. Now, I flat out told you, but you could also get that by adding the water and the pineapple juice. So what is your answer? You take 55 divided by 100, and then times 100 to get 55%. So if you just have 100 milliliters total, yeah, I can just say, oh, 55 out of 100, that's 55%. But if I give you a different total, like let's say I change this and to that, now it would be out of a 95 milliliter solution. So now I would have to take my 55 divided by my total, and then times by 100 to get a percent. Okay, so that's why it's divided by 100 times 100. If I have one big bag of salt that is a solid chunk and one big bag of salt that is fine crystals, so the same size bags, which one will dissolve faster and why? The fine salt will dissolve first because it has more edges and therefore more surface area that can be attacked or broken down by the solvent at the same time. You can also think of it this way. Dissolving is breaking things down into little pieces, right? That's what dissolving is. Dissolving is breaking things into little pieces. And if you already have smaller pieces, you're halfway there with the fine salt, so it's like half the work has been done for you. So it's going to take less time to dissolve overall. Do higher or lower temperatures cause a solid to dissolve faster? And actually, I really could just replace this with the word solute because it's true for all of them. Answer: the higher the temperature is, the faster the molecules are moving and the more they are colliding. Therefore, a higher temperature equals a faster dissolution rate or speed of dissolving. Because it's moving faster, you're having more collisions, more breaking it down in the same amount of time. Alright, so we have dissolution, rate, insoluble, and dissolution rate. Alright, so go ahead, hit pause, match them up. So dissolution means dissolving or breaking down of a solute in a solvent. Rate means how fast anything happens. Therefore, dissolution rate means the speed that something dissolves. And insoluble means it cannot dissolve. So in, like impossible. Insoluble, cannot. Be soluble, cannot dissolve. What is the formula for finding molarity? You have a cheat sheet. You better be using it. It is moles of solute per liter of solution. Well, what does that mean? What does that really mean? Can you put that into words? It is how many moles of a solute are dissolved in 1 liter of a solution. A solution is made by adding 50 grams of carbon monoxide to enough water to make 2 liters of solution. What is the molarity of the solution? So first thing, write down everything you know and write down the unit you are solving for at the end. So we know 50 grams of carbon monoxide is a solute. We know we have 1 liter of solution. And what are we solving for? Molarity. And what is the unit of molarity? Moles per liter. Alright, so start with what we know. We have the liters, right? We have the 1 liter of solution and we have 50 grams. But we don't want grams. What do we want? We want moles. So we got to turn grams into moles. So we have 50 grams. What unit has to go on the bottom of our next fraction? It has to be grams because we need them to cancel. And mole is our final unit in this portion. So now we need to figure out how many grams of carbon monoxide are in 1 mole. And your hint is use your periodic table that I threw on the bottom of the screen. So there's 1 carbon and 1 oxygen. And so we're rounding to hundredths, so 12.01 plus, what is 15.999 rounded to hundredths? Think of it like money. It's $15.99 and a tiny bit more. So $15.99 is almost paying $16. So our mass is 28.01. Alright, so we put that on the bottom. Now put it in your calculator. We multiply everything on the top, divide it by everything on the bottom. And we get 1.79 moles of carbon monoxide. Alright, now what? We want to find moles per liter, so we would do what? We know how many moles we have now. What do we have to do? Divide it by our liters. So 1.79 moles divided by 2 liters equals 0.895. Alright, round that to hundredths. So think about money again. If I have 89 cents, a little bit more than 89 cents, add a penny, it would be 90 cents. Alright, next question. If there are 5 moles of copper dissolved in 20 moles of zinc to make 25 moles of brass solution. What is the mole fraction of copper? Alright, and so make a list of what you know. And for this one, think about the word fraction and what the word fraction means. Fraction means part of a whole. So what part are we looking for? How much is the entire thing? We're looking for 5 moles of copper, and the entire thing is 25 moles. And what do we do now? We take 5 divided by 25 times 100 gives us 20%. So 20% is copper. There are 50 grams of ethanol dissolved in 70 grams of water. The molar mass of ethanol is 46.07 grams per mole. How many moles of ethanol are there? Alright, so again, go through, make a list of what you know. Alright, you know you have 50 grams of ethanol. We know we have 70 grams of water. We're trying to find moles of ethanol. Okay, we need to convert grams into what? Into moles. What's the first thing you're going to write down in your fractions? 50 grams of ethanol. What has to go on the bottom of my next fraction? Grams, so they cancel. And what's my final unit going to be? My final unit is moles of ethanol. Alright, what number goes down here? In 1 mole, we have 46.07 grams of ethanol, and I gave it to you in this case. Otherwise, you would have to look on the periodic table. And our answer, 50 divided by 46.07 gives you 1.09 moles of ethanol. Alright, so I want you to hit pause and tell me how many moles of water there are. So for moles of water, we have 70 grams to start out with. And again, we have our fractions. So grams of water has to go on the bottom. If you look on the periodic table, each oxygen weighs 16. Each hydrogen weighs 1.01, and there's 2 hydrogens. So 2 times 1.01 for our hydrogen plus 16 for our oxygen gives us 18.02 grams of water per mole. So 70 divided by 18.02 gives us 3.88 moles of water. How would we find the mole fraction of water? Okay, so remember, fraction means part of the whole. So we would take 3.88, because that's how many moles of water we have, divided by 4.97. Alright, where did I get 4.97 from? I took my total. I took 3.88. So I took 3.88 because that's how many moles of water, and to get my total, I added how many moles of ethanol, and I get 4.97. So I took my portion, that's water, divided by my total, and that gives me my fraction. For fractions, we do not multiply it by 100 because we do not want a percent. We just want the decimal or the fraction. Suppose you had 10 moles of sugar and you dissolved it in exactly 5 kilograms of pure water, the solvent. What would the molality of the solution be? Alright, so look on your cheat sheet, write down everything you know. We know we have 10 moles of sugar, 5 kilograms of water. Our final unit is moles per kilogram. So what do? You do 10 moles divided by 5 kilograms equals 2 moles per kilogram, and that is your molality. Why do different parts of ink separate at different points or places in the paper in the chromatography? So I put a dot of a marker here and it's spread out into the different colors. Why does the red end up here versus the blue here? The smaller the molecules, the more they can move. So the smaller, they move faster and farther, whereas the large molecules are slow and don't move nearly as far. So which color molecules are smaller, red or blue? Well, it would be the red because it traveled the fastest and the farthest. Why does Kool-Aid freeze at a lower temperature than water? Hit pause. The molecules of solute in the Kool-Aid solution, so the water, the chemicals, the sugar, basically get in the way of the water molecules, making perfect crystals, and therefore it takes a lower energy level for the Kool-Aid to freeze at. So Kool-Aid freezes at lower temperatures than pure water.